sklearnmetrics root mean squared log error. Description: the root mean squared logarithmic error (RMSLE) is a regression metric that measures the ratio between the predicted and actual values. It is a useful metric when dealing with data where the magnitude of the errors is important, such as in financial forecasting. Inputs: y true, the true target values. It is a 1D array-like structure containing the actual values for each data point. Y pred, the predicted target values. This is also a 1D array-like structure containing the predicted values for each data point by the model. Outputs: RMSLE, a scalar value representing the root mean squared logarithmic error. This value is typically non-negative, with a lower value indicating better model performance. Steps: calculate the natural logarithm of both the true and predicted values. Calculate the squared difference between the logarithms of the true and predicted values. Calculate the mean of these squared differences. Calculate the square root of the mean. Metrics: RMSLE provides a measure of the average logarithmic error, useful for evaluating models that predict values with a wide range. It is particularly useful for cases where the model's errors are more significant when predicted value is far from the actual value. Visualization plots. Residual plots can be used to visualize the distribution of the errors, the difference between predicted and actual values, and assess whether the model has systematic biases. Fine-tune parameters. None. This is a metric function, not a model. It does not have parameters to be fine-tuned. Uncertainty methods. Confidence intervals can be used to estimate the uncertainty around the predicted values. Challenges and fixes. Challenge 1, 0 or negative values in y true or y pred. Sample use case that resulted in challenge 1: if your dataset contains 0 or negative values in either the actual or predicted values. The logarithmic transformation involved in RMSLE might lead to errors or undefined values. Fixes to challenge 1: handle 0 or negative values using techniques like adding a small constant to both y true and y pred before calculating the logarithms. This can help avoid undefined values and ensure the metric is calculated properly. Challenge 2: sensitivity to outliers. Sample use case that resulted in challenge 2: if your dataset contains outliers. These can disproportionately impact RMSLE. Fixes to challenge 2: consider using robust error metrics or data preprocessing techniques to mitigate the influence of outliers.